Good morning. Welcome to Lesson 3 Notes in Module 6. The title of Lesson 3 is Names and Formulas of Ionic Compounds. These notes were taken on Friday, February 10th. Hopefully you're filling in the headers on your Cornell note-taking sheets. The focus question is, what are the names and formulas of ionic compounds? And that's what we're going to figure out how to write today. And then, as always, you can pause the video, fast forward the video. You also are going to want a periodic table out. And here we go. This is some of the new vocabulary. Today we'll concentrate on the terms formula unit and monatomic ion. We've got some review vocabulary here. A nonmetal. You should probably put this in your notes. What we should remember is that nonmetals, they are an element that is generally a gas or a dull, brittle solid and is a poor conductor of heat and electricity. Some other things you might recall about nonmetals is that they always want to gain electrons, so they're going to be anions. They're going to form anions with a negative charge. And remember, these are the elements to the right of the staircase on the periodic table. Those are the nonmetals. And then there is one exception, hydrogen, way over on the left side. And then remember that the noble gases in group 18, they aren't going to form any compounds at all. Okay, so here we have a formula unit, and I'm just going to put up the definition. The definition is the simplest ratio of ions involved in an ionic bond. What a formula unit basically is it's you writing the formula for an ionic compound. When ionic compounds form, they form something called the crystal lattice, and you're probably going to want to put this example in your notes. But a crystal lattice would look something like this. We would start out with magnesium, the ion, +2. Remember, there's no dots around it because it has given away its 2 electrons. That's what the +2 means. Then I'm going to put a Cl with 8 dots around it. Remember, chloride took an electron. It's got a -1. And over here, I've got to do another Cl with a -1 charge. Okay, so we've talked about how ionic crystals aren't going to be large enough to see if those are the only 3 ions. So what you need to do is you need to repeat that pattern hundreds of thousands of times in order to get big enough to see 1 crystal of salt. So I'm going to repeat the pattern again. Remember that it's got to be an alternating pattern of positives and negatives. So here underneath the chloride ion, I'm putting the positive magnesium ion. Then I'm going to put another chloride over here. Remember, the charges, positive and negative, have to be offset. Okay, I'd like you in your notes to repeat the pattern one more time. I'm going to do it again. Here I'm going to put a chloride ion down here. Here I'm going to put a magnesium ion. And then let's do another chloride ion over here. And again, we're repeating this pattern, this crystal lattice, until we get a crystal that's big enough to see. So what we're drawing here in the picture is the crystal lattice. And a formula unit is the simplest ratio of ions involved. The simplest ratio of ions would be a neutral compound with no charge. And so I'm going to circle a formula unit or put a box around it here. This is 1 formula unit of magnesium chloride. We've got a +2, and it's balanced out by the 2 -1s. That is what we would call a formula unit. A formula unit is the simplest ratio of ions that is going to be neutral in an ionic compound. And we can abbreviate formula unit FU. That's going to come in handy a couple of chapters from now. But again, a formula unit, and I'll put a box around another one, is that simplest ratio of ions that will go together. So when we write formulas for ionic compounds, we are actually writing the formula for a formula unit. Okay, I'm going to get rid of these notes, and then I'll go to my next slide. Here's what monatomic ions are. Monatomic ions are a one-atom ion. So we've got an example of Mg2+. Remember, magnesium always wants to give away 2 electrons. Or bromide wants to take an electron. It's in group 17. If you take a look down here, I've got, here's group 1. It always has a 1+ charge. All of those elements have 1 valence electron that they want to give away, so they're going to want to have a 1+ charge. In group 2, they have 2 valence electrons. They want to give away 2. They're going to have a 2+ charge. Here in group 16, the oxygen family, they have 6 electrons, so their charge is going to be -2 because they need to gain 2 electrons to become stable. They're going to form an anion with a -2 charge. And then here are the here are the halogens. They need to gain 1 valence electron, so they're going to form monatomic ions with a -1 charge, okay, because they gain that 1 electron. If you remember when we folded the periodic table so that we could only see the representative elements, those columns that stick up, we covered up the D's, okay? So if you fold the periodic table, there are only 8 groups left. Those are the representative elements. And if you guys want to write across the top of your folded periodic table, you could write the charge that each one of those ions is going to have in an ionic compound. So above group 1, you could write +1. Above group 2, you could write +2. Group 13, remember we folded the periodic table, so now we're looking at the boron and aluminum group. That would be the 3rd group over. That's going to be +3. Carbon family is going to be ±4. And then you guys, if you look at the nitrogen family, okay, that's group 15. They have 5 valence electrons, so they want to gain 3 to become stable. They're going to have a -3. -2 above the oxygen family, -1 above the halogens, and 0 above the noble gases because they won't do anything with their valence electrons. If you're smart, you will memorize that order going across the periodic table. +1, +2, +3. When you get to the carbon group, it's always ±4. And then it's -3, -2 in the oxygen family, -1 in the halogens, and then 0 for the noble gases. Those are monatomic ions. We need to know their charges in order to write formulas. Okay, here are the rules for writing chemical formulas for binary ionic compounds. Binary means there's going to be 2 elements. Ionic means there's going to be a cation and an anion, and they're going to form a neutral compound. So here are the rules. I'll let you copy those down. But the first thing we're going to do is we're going to write the cation. Remember, cations are formed from metals, those things on the left side of the periodic table. We're going to write their symbol and charge. Then we're going to do the anion. We'll write that second, okay, symbol and charge. And then we're going to balance those charges at 0 using subscripts. And what we need to remember is do not use the subscript 1 as a subscript. If you guys think of the formula for water, H2O, there's 2 hydrogens. That 2 is for the hydrogens. And there's only 1 oxygen, but we don't write 1 when there's only 1 of an element. The symbol of that element tells us that there's only 1. And then sometimes in books, you will see this term, oxidation number. What oxidation number is it's just a fancy way of saying the charge of the ion. Okay? So oxidation number is the charge. Okay, we're going to do some examples now. I'll show you how I'd like you to do these. You've got to open up to page 183 of the text. There's problems number 19, 20, 21, 22, and 23. And I just want to show you how to do those. Remember, you can pause the video at any time. So the directions say, write formulas for the ionic compounds formed by the following ions. Use units as a guide to your solutions. I'm going to show you how I want you to do these problems. You don't have to do it the way the book is showing you to do. On the left hand, on page 182, if you look at how they evaluate the answer, oh my gosh, I don't think anybody would ever do anything like that. But I want to show you the minimum amount of work that I need from you. So the first one says potassium. I'm just writing the problem. You don't need to rewrite it. But I want to show you the work that you need to do. So the first one says potassium and iodide. So here's what you do. You follow those steps that we just wrote down. So step one is write the cation, symbol, and charge. So we're going to do potassium, it's a K, and it's a +1 charge. That +1 goes up in the air as a superscript. Then we're going to do iodide. We're going to do I and -1. And remember, I'm getting those charges from the folded periodic table. Remember, a few minutes ago, we talked about how group 1 is +1, group 2 is +2, group 13 is +3. Remember, we folded the periodic table. Group 14 is ± 4. Then we go -3, -2 on the oxygen family, -1, and 0 on the noble gases. So the next thing we need to do is we need to get our positives and minuses balanced. Well, if you guys look at this, potassium's a +1, iodine's a -1, they're already balanced. So we don't have to add more of either one. If you think about it, potassium's going to have 1 valence electron. It's going to give it away. Iodine's going to take that 1 valence electron, and it will get the -1 charge. So what we do is, since it's a match made in heaven, we write our formula as Ki. That's the formula, no charges on it. This is the work over here on this side, okay? And then over here, this is our neutral formula for our binary ionic compound. And then we have to name it. And to name it, we're going to call it potassium. And then put a space, and then iodide. Now, why isn't it potassium iodide? It's iodide because we changed the names of negative endings, negative ions, and we change it to the 3 letters IDE. Okay, problem number 20. I'm not actually going to write the problem down, but let's go ahead and do it. Problem 20 is magnesium and chloride. You can pause the video and look up the charges if you need to. Magnesium's a +2, chloride is a -1. So here our problem is our charges aren't balanced. In order to balance them out, we play the least common multiple game. What's the first number that both 2 and 1 will go into? Get your positives and negatives to the least common multiple. The first number that they'll go into is 2. So what I'm going to do is, since magnesium's already at 2, I'm going to add a second chloride to get that to -2. Then the positives and negatives will balance out. So I'm going to write for my formula, MgCl2, and then we're going to call that magnesium chloride. Remember, there's a space between those two names. Okay? Let's go ahead and do problem number 21. Again, you can pause the video if you need to. You can work it out on your own. Problem 21 is aluminum and bromine. So here's aluminum, here's bromine. I've got a +3, and I've got a -1. We need to get them to the least common multiple. The first number that both 1 and 3 go into is 3. So aluminum is already at a +3. Let's get the bromine to a -3 by adding 3 of them. So my formula is going to be AlBr3. Be very careful with the size of your letters. Remember, in chemical symbols, the first letter is capitalized, the second letter is lowercase. Okay, and then I'm going to call this aluminum bromine. Okay, no worries. Okay, we've got 2 problems left to do. Let's get to problem number 22. It's cesium and nitride. Pause the video if you need to. It gets a +1 and a -3. Here I need 3 of cesium, the -3 of nitrogen, and then I need 3 of the +1s to get to +3. So my formula is CS3N. And then my name is going to be cesium nitride. And remember, we changed the name of the negative ion. It's not nitrogen. We're going to change it to nitride. And then lastly, 23. 23 says to write the general formula for the ionic compound formed by elements from the two groups shown on the periodic table at the right. You guys, for group 2, just use the symbol X. It can be any element in group 2. In group 17, use Y, any element in group 17. If you're in group 2, your charge is +2. If you're in group 17, your charge is -1. So least common multiple would be to get them both to 2. So we're going to have to add 2 of the Y's to get it to a -2 to balance the +2 of the X's. So we're going to call this XY2 as our general formula. If we had to name it, which we don't, we could call it something like Exium Y-tride. And we'd have to change that ending to "ide." Okay, I've got one last thing. We're going to write this down in our notes on Monday, but I want to show you guys something. I need you to find iron on your periodic table. So if you guys would find iron, there's just something I have to show you. Iron, it's a transition metal. We'd have to unfold our periodic table. There are a lot of elements, mostly transition metals, that have more than one charge. Since these are metals, they can have positive or they have to have positive charges. They can never be negative charges because they're metals. So I have here some elements, mostly transition metals, have multiple charges. Their charge will be given to you as a Roman numeral. You must include the Roman numeral in the name. You guys may want to copy down this list of Roman numerals, okay? So you may want to copy that down. And what they're going to do is they're going to give you the Roman numeral after the name of the metal, and that's the charge you're going to use. Iron, if you're looking on your periodic table and you have the charges written in the boxes, I think iron can be a +2 or a +3, okay? You've got to make sure you use the one they give you in Roman numerals. And we'll do a couple examples of this, you guys, on the worksheet. So would you take out the worksheet? I want to do 2 problems on the front and 2 problems on the back with you. So let's go to that. You'll need your periodic table out. Let me switch over to where the worksheet is. And we're going to do these problems quickly. And this is the same amount of work I need to see from you. So do not do any less work than I am showing you on this worksheet. Otherwise, you will not receive full credit. So here I've got sodium and sulfur, okay? The directions say, using the oxidation numbers, that's the charges, write the formula and name of the compound formed by the elements, include work showing the charges. So here's what I need. You're going to write sodium, and it's a +1. And you're going to do sulfur, it's a -2. You get these by using your periodic table. You're going to balance them out to be least common multiple. We want to get them balanced to be neutral. So I need 2 of the +1s to equal the -2. So I'm going to write Na2S over here in the margin. You have to do it small, you have to do it neat. That's going to be my formula, okay? And then I'm going to call it, you have to name it, sodium, put a space, and then it's not sulfur, negative ions, we change the name, and we're going to call it sulfide. Got to have that IDE ending on the negatives. Okay, I want to do one more if that's okay. I want to do number 12, aluminum and oxygen. So if we go down to number 12, aluminum and oxygen, if you want to pause the video to figure out the charges and write the symbols, do that and then push play. But I'm going to do it right now. Here's aluminum. It's a +3 charge. Oxygen's a -2. This one's a little more difficult. How do I get the charges balanced at 0? Well, you do what's called least common multiple. I'm not a math teacher, and as juniors in high school or seniors, you should know what least common multiple means. It's what's the first whole number that both 2 and 3 will go into evenly. Well, it's not 2, because 3 can't go into 2 evenly. Okay? It's not 3. They both don't go into 4. They both don't go into 5. Uh-oh. They both go into 6. You need 2 of the plus 3s to get to a positive 6. You need 3 of the negative 2s to get to a negative 6. So our formula is going to be Al2O3, and we're going to call this aluminum oxide. Remember to change that ending. Okay? So there's a couple examples. I want to go over to the other side. On the other side, there's going to be some examples with the Roman numerals. Okay? So here's your example. Let's do number 5. 5 says copper, Roman numeral 2, okay, and then iodine. So we're going to do copper, and it gave us the Roman numeral 2, so that's a plus 2. Whenever they give you Roman numerals, they're always positives, and then iodine is a negative 1. So in order to get these balanced out neutral, iodine, I'm going to need 2 of the negatives to balance out the positive 2. So my formula is CuI2, and the name of this compound is copper, and then a Roman numeral 2, and iodide. Remember, we have to change that ending to "ide." Okay? I want to do one more with you, if that's okay. So let's go over and let's do number 18. 18, and again, we're on the B side here, is lead 4 and oxygen. So let's do lead, and Pb is 4, that's IV, so plus 4, and then oxygen is a minus 2. What's the first number that they both go into? It's not 8. The first number that they both go into is 4. Lead, you need 1 of them to get to plus 4. Oxygen, you need 2. 2 times minus 2 would be a minus 4. So we're going to do PbO2. And that is the formula for lead. Then remember, you have to include the Roman numeral. The reason you need to include the Roman numeral is what if somebody wanted to work backwards from the name that you give them to write the formula? They wouldn't know what charge to use. So it's going to be lead, Roman numeral 4 in parentheses, and then a space, oxide. One thing that I forgot to mention to most classes on Friday, but I'm going to mention it now, is that zinc, it's a transition metal. Zinc is always going to have a plus 2 charge, and you'll never use a Roman numeral. Okay? So zinc's a plus 2 charge. It is a transition metal, but it's always going to be a plus 2, and you are never going to use a Roman numeral with it. The same thing with silver. Silver, transition metal, but it's always a plus 1, and that's just something that you need to know. You're going to get a sheet on Monday that will tell you these things. I'm going to go to the front side of the worksheet, the A side, and I'm going to write that again. Zinc is always a plus 2, no Roman numeral needed, and silver is always a plus 1. Okay? Thank you for tuning in, students. If you have problems with this, come in after school Monday or Tuesday. And remember, we are testing on Wednesday. Have a good rest of your weekend.